Physical properties and molecular structure. So there are three physical properties that we need to focus on in organic chemistry. They are the melting point, the boiling point, and solubility. And all of these depend on the strength of intermolecular forces. If you haven't watched the video and you need to recap, go for it. It should be uploaded in the same folder as this video. Okay, so let's cut to the chase. So we have melting points. The general trend is that ionic compounds have a higher melting point, well, much higher melting point than polar compounds, which have a much higher melting point than non-polar compounds. Now, of course, the stronger the intermolecular force, the stronger the things hold together, and therefore you need more energy to cause them to split, i.e. go from a solid state into a liquid state where they are more mobile. Another important factor, of course, is size. So as size increases, the melting point increases. And then, interestingly, the more symmetrical or compact a structure is, the higher the melting point. Alright, so what does that look like? So if you have a structure that is a long chain versus something that is more of a cross, that is symmetrical, this one will pack better. Therefore, it will have a higher melting point. What about boiling points? Well, same trend. Ionic compounds have a much higher boiling point than polar compounds, which are much higher than non-polar compounds. Another trend, of course, larger the molecule, the higher the boiling point. And then, interestingly enough, branching, which previously kind of gave us symmetry and whatnot, branching actually decreases boiling points. So if you have a compound that is a chain, and then you have a similar compound with two branches off it, this one will have a higher boiling point. Higher boiling point. Alright. I mean, this is a good thing though. On the flip side, as it's at lower boiling point, it will burn better. So that is why the gasoline that you pump into your car tends to be branched. So gasoline equals branched, because the lower the boiling point, the more fumes you get, and therefore a better explosion you get in your combustion engine. Right, and then finally we have solubility. This one, it'll probably be better if we do practice problems in class when we get back together, but like dissolves like. So in other words, polar dissolves polar, nonpolar dissolves nonpolar, so in other words, if you think about it, water is polar, therefore polar things dissolve in water, and this is where in biology you get the term hydrophilic is right, hydrophilic, because it loves water. And nonpolar compounds are referred to as hydrophobic. Now go back and look at biological compounds that you might have come across that are referred to as hydrophilic and hydrophobic, and I guarantee you will start noticing that, oh, the hydrophilic side has alcohols, or OH groups and things like that that make it polar, whilst the hydrophobic ones will be just long carbon chains that do not have any polarity.